In today's lesson, I will teach you 4 rules that will allow you to ace the exam questions. Before I begin, I would like to thank all the 9 subscribers and the reactions across my social media platforms. I received 2 emails asking for help in redox reactions and Newton's laws of motion. I will load the content soon. Let's begin today's lesson. We're looking at what we call academic constitution, right? Now, this academic constitution is a rule or a constitution, right, that we will use in our Scienceless channel in order to solve problems. So it provides us with rules or step-by-step procedures that we need to solve chemistry and physics problems. Remember that physical sciences is broken into 2 parts, right? Chemistry, which is paper 2, and physics, which is paper 1, right? These 2 subjects, they really are closely related, hence they've made them one subject. So the way you solve them, you use the same techniques. So our academic constitution says that the first rule that we need to learn is that of problem interpretation, right? Problem interpretation. Now, in this rule, what you do is that when you approach a problem, you read the problem statement and study the given information. Now, this information that will be given can come in the form of diagrams, pictures, graphs, and or tables, right? That's how we scientifically represent data, right? So you read that in a situation where you're not provided with a diagram, make a quick sketch, right, that will assist you to visualize the problem. It's important for you to be able to visualize the problem because physical science, the word physical science, physical would mean something that we can perceive with our 5 senses, right? Something that we can perceive with our 5 senses. 1, we can see it. 2, we can hear it. 3, we can taste it. 4, we can smell it, right? I think the last one would be we can touch it, right? We can touch it. The last one would be that we can touch it, right? So it's very important for you to be able to study these diagrams or draw diagrams that assist you to physically understand this problem, because physical sciences is about our 5 senses. We deal with physical quantities that we can see, hear, taste, smell, and touch, right? After doing that, you then choose direction, right? The way you choose direction, you can use words, right? When you use words, you can come here and say maybe take right as positive, right? Or you can write something like choose down as negative, right? It's your choice in terms of how you choose direction. We'll talk about that specifically when we do questions. I'm just breaking down what you need to do when you solve a problem. The other way to choose a direction really is to use a reference frame. A reference frame is a set of Cartesian plane, right? It is made up of the x-axis and the y-axis. So you can choose that anything that is along the x-axis is and going to the right is positive, and anything that goes up there in the y-axis is positive as well. This means by default that anything that goes in this opposite direction would be negative, and anything that goes down will be negative. That's another way of choosing direction. We call that the reference frame. The other way in which you can choose direction is by the use of the cardinal directions, right? So the cardinal directions really is you using our cardinal points, right? Where you choose direction based on the cardinal points. So the cardinal points will be your north, east, south, and west, right? Then you can choose from here that maybe east is positive and north is negative. It's really up to you. You can choose it the way you like, but these are the three different ways in which direction can be chosen. After you have chosen the direction, and also direction, you really choose it when you deal with vector quantities, right? After you've chosen direction, you then go to writing down the known values and also unknown values, the ones that you don't have, right? And then you write this on your answer book or directly on the diagram that you are given on the problem, right? You can put that information in there. This will assist you now to move to the rule number 2, right, which talks about problem classification. Remember, at this stage we have a full understanding of our problem, right, and we know what values we are given and we have chosen direction. What we then do from that understanding is that we connect that problem to the concepts, the laws, the theories, and the formulae that we already know, the knowledge that we have studied. We connect that problem that we're given to the knowledge that we know. If you are reading the problem and you can see that this problem uses stoichiometry, right, and then already you know that you're gonna do calculations that involve stoichiometry. You have to balance chemical equations, and your problem will be around that. If you read a problem, you can see that this problem speaks about Newton's second law. Already you know the formula that you're going to use. F is equals to ma. You have a clue of where you are going now, right? So because the first step, you have an idea, right? Now this is important now because it leads you directly to our rule number 3, where we are ready to answer the question. I mean, we already know what problem we're dealing with. It's just a matter of answering the question. We know what theories, concepts to use in this problem. When we read the problem, we can see where the examiner is trying to go or what they're trying to achieve with their problem. Now, there are two questions that you will get in your exams, right? One of the questions that you'll get is a question that focuses on concepts, right? This is a type of question that will ask you about the law, state the law, or they'll say provide a brief explanation. They'll give you a scenario and say, explain why this is the case, or explain how this is the case, right? Explain why this is the case, right? So those are questions that focus on concepts, right? These are really straightforward questions, but I know they can be tricky and difficult for the learners, which is why we are here at the Scienceless channel, for me to provide you with support and make it easy for you to answer these questions. I have done a compilation of study guides that I'll be giving you for free as I roll out these lessons. I'll provide links to the study guide. You can go to the link and download those study guides for free. They're easy to read. They go straight to the point. They teach you how to answer these questions in a straight and concise manner, right? Because the other biggest problem that I've experienced working with learners, some learners like to write long questions when they have to answer this type of questions that focus on concepts. You'll find that the question is for 2 marks, but the learner would be writing a long essay question, right? And remember, in physical science and chemistry, it's very rare for them to ask essay questions. They normally would ask you a question that's worth 1 mark, 2, 3. I think the longest that I've seen is 4 marks, where they ask you to explain something. So it never really is requires you to write a long answer, right? But I'll teach you about this as we go in our lessons. Right. The other type of calculation that you will get is calculation questions. Right. Obviously, at this stage, we know what formulae to use based on how we have read the problem from, problem interpretation and problem classification. Right. It means now at this stage, you just choose the correct equation that you need to use in solving that problem. And after choosing that equation, you just substitute now into that equation to really get your answer, right? After getting, sometimes some of the questions are not that straightforward, right? There may be simultaneous equation where you have to calculate other things before you get to the final answer, right? In chemistry and physical science, you'll find that your answers are normally represented as decimal numbers, right? And they will be having decimal, after a decimal point, there will be a lot of numbers. So the tradition here is that this is also part of your exam rules to say always round off your answer to 2 decimal place unless they tell you to round it to a whole number or 3 decimal place or anything of that nature. Otherwise, put your answers in 2 decimal place. So here let's quickly wrap up on this. Under problem answer, you have focus questions. So these questions, they need you to up your game in terms of memorizing. It's just a matter of you going to study the theory, the concepts, the laws, and you just provide that, right? So it should be easy marks. I'll teach you in terms of providing explanations. Second one, we run calculations. Again, we'll be doing a lot of calculations in our channel where I teach you skills and techniques and provide warnings there and there in terms of how to best solve problems, right? Usually learners would get the answer and they move on, they're happy, they stop here, right? We're going to change that narrative with the Scienceless channel, because there's the last part which is extremely important, right? Which is the fourth rule under our academic constitution that says problem navigation. Now, this involves you checking your final answer to see if it makes sense, right? And also if it has correct units. I just want to give you a quick example here. Let's say you have a bicycle, let's say you have a bicycle here, a person on a bicycle, and then you were doing a calculation where you're getting the velocity of this bicycle, right? And you get that the velocity is 200 meters per second after you have done your calculations. Let's say you are at that stage. This is your final answer here, right? When you navigate this problem, and perhaps maybe because it's velocity, we can also put direction to say it goes to, let me just say, east. Can I use east? Yes. Let me just say east. It goes to the east. Now, if you look at this answer here, 200 meters per second is a very big number for a bicycle. It is not possible in the physical world. As I said, physical science, right? There's no way we can see. We can observe, right? Such a physical phenomena where a bicycle moves at 200 meters per second. It is not possible. I mean, this is comparable, right, to the speed of a bullet. So a bicycle cannot move at the speed of a bullet. Already this answer, when you navigate this answer, it tells you that there's something wrong that you have done in your calculation. So, that's why I'm saying this part is important, because already as a learner, you can judge your answer and sort of pre-mark yourself, right? I use the word pre-mark because remember, maybe we don't know the actual answer, right? So you can pre-mark, you can have an idea of how well you did on your exam by just navigating your answer to see that. And also another thing is that when you check direction, direction we use negative and positive. I'll talk more about that when we do vector quantities versus scalar quantities. So sometimes when you check your direction, you find that maybe you expected your answer to be to the west, right? Then maybe that's a problem. So you have to check that. And also the SI units are there. You have to check if they're correct as well. That's the first part in terms of you navigating the problem, right? I mean, getting an answer that's around things such as maybe 6 meters per second, maybe to 10, I believe that could be reasonable, right? This is a very good answer to get for a bicycle. It makes sense, right? Another way to navigate a problem really is to look at your answer, your final answer, under different conditions, right? So what you do is that you look at other variables in your calculations to say if those variables they change, how will your final answer change? If those variables change, how will your final answer change? Will your final answer increase, decrease, or become zero? Sometimes we even say remain the same. Will it remain the same? You look at it, how will it behave? And of course, there will be expected answers for it, right? So if we were dealing with a velocity, we would expect it to change in a certain way, right? And if it does not conform to that, or it does not change in the expected way, that gives us clues to say our answer may be wrong, the answer that we have calculated. So let's say if we were calculating this answer here, it gives us clue to say this answer may be wrong if it does not conform to our expectations in terms of these options that we have here, right? So this technique is very important in also assisting us to have a feel if we are in the right track or if we are getting the correct answers. Now, this part here, also the examiner likes to put it in the exam papers. I've seen this a lot in the exam papers where they say something changes, right? How will the other one behave? Will it be we're looking at the answer at different conditions. Will it increase, decrease, remain the same, or even become zero? So and a lot of people are saying those questions are difficult, they don't like them. And I argue that actually what the examiner is doing there, they are assisting you to assess your answer if it is correct, to see if there's any errors in your answer. That's why they like asking this question, right? But I'll teach you how to answer these questions and how to maneuver around, how to look at different conditions to get the same answer, if you stick with us in all our other lessons that we'll be sharing, right? Because I'll give you the skills as well of answering these questions and looking at them and making sure that your final answer makes sense. Guys, I just want to wrap up what we have done here by quickly looking at how to remember this constitution that we have just developed in the science channel, right? So this constitution really says I can. So it serves as a mindset. It's a mindset that I'd like you to develop as you are approaching your exams and use it to actually tackle your exam problems. Because here, it's a mindset that you will have when you approach problems and exam questions. When you start feeling nervous by seeing a question paper and looking at the diagram, the statements, you then write this at the top of your questions to say, I can solve this problem. Why? Because you have all the tools. You know the step, but you have the rules, the constitution that will guide you in solving the problem. Now, this constitution says I. The I is for interpretation. The C is for classification. The A is for the answer. And the N is for the problem navigation. Right, the problem navigation is for navigation. So it's a belief or a mental belief that I like you to adapt to say, I can solve the problem. That's a mnemonic that you need to memorize or have it in your mind. Very easy to remember when you solve problems to say, I can solve the problem. This is the end of our lesson today. I will be loading a series of lessons on Newton's laws and also doing the problem that I received. And also I will be uploading a series of lessons as well on redox reactions chemistry for grade 11. Guys, thanks. See you in the next lessons. May the force be with you.